Okay, friends, it's Miss Blatch here. How are you? This is one more time I'm going to try. This is about the third time I've tried to record this, so I'm not going to rewrite the words here, so hopefully you won't have any difficulty understanding what I'm about to say. I'm going to highlight here with a pen, and that will help you see what I'm talking about. So write the correct answers down, and make sure you show your work when you do this on your corrections. Some of you are just giving me a list of answers. That is totally not acceptable. I realize that sometimes there's no work to show, but when there is work to show, you need to show it, okay? And I'm not going to accept it if you don't. Okay, so some suggestions here. For this one, this is an addition problem, so therefore you do not need to change these signs. So ignore the parentheses and just combine like terms, and that's how you get 1A. 1B, this is a subtraction problem. So now you do have to distribute and combine like terms. So the first one does not change, so this remains 3b squared plus b minus 7, just like that. This one, you distribute the negative in so that all three of these will change. So the b squared was positive, now it becomes negative. The 4b was positive, it becomes negative. The 2 was negative, it becomes positive. That's because you distributed this negative in. Now you have combining like terms. And the answer is 2b squared minus 3b minus 5. Would it help you if I said them? I think I'll do that. I think that might help you. Okay, letter C. The correct answer is negative 12a to the 6th power, b to the 4th power. This is multiplication, so right in here there's a multiplication problem. I can't do that with this big thing. But anyway, that's multiplication. So you would add the exponents. This problem, letter D, is power to a power, so you'd multiply the exponents. Hence, negative 27. X to the 6th power, y to the 12th power. Letter E, you have two things you have to do. First, you have to raise power to a power, and then you need to multiply them together. So, and a lot of you forgot to square the 5. 5 squared is 25. V to the 4th squared, that's V to the 8th. Then when you add, multiply them and add the exponents, you get negative 50 V to the 11th. Okay? F was a great one. I hope you were happy with that. You get 2 whole points for just saying that anything with 0 power is 1. Good job. Letter G, two things you needed to do. You need to multiply first each of these and then do the addition problem. So this is just order of operations. I wonder if you remember, did you remember seeing this one in the stations? It was exactly this problem. I didn't even change the numbers, silly me. Okay, so be aware that I might do that sometimes. It's totally by accident, but I did it this time. So you multiply these, you get 15x to the 4th and 16x to the 4th. Then when you combine like terms, this exponent does not change. Many of you changed that. Letter H, notice that the fractions canceled, the 5s cancel, the 2s cancel, because you're multiplying. Then you just multiply and add the exponents. A to the 5th, b to the 8th. Good problem. Letter I is a negative exponent. What do negative exponents give you? Nope, not negative numbers. A couple of you told me it was negative. It's not. It gives you a fraction, so that's 1 over 25. J was a big bugaboo. This was a problem for a lot of people. So it's order of operations, and you are going to get to practice this week. So if you're seeing this early on, then you will get to practice this. If you're seeing this late, then you will have already practiced this, so hopefully it'll help. When you substitute a negative number, see how b is a negative 2? You need to plug that in using parentheses. See these right here? So the problem is well, you had more than one problem. One of the problems was you didn't put the parentheses around that, and that caused difficulties. The other problem you had was that there were 2 exponents, and that bothered you. My solution to that is just to order of operations. I have multiplication here, I have an exponent here, and then all of it is to this exponent. So I just did what was inside this parentheses first. So negative 2 squared is 4. Leave the 3 times 4. Leave the exponent. You're going to do that last. Then do 3 times 4, which is 12, and then square that. So that's an easier way to think about it. A lot of you tried to do it with the exponent laws. That just makes it more complicated, I think. I mean, it can be done, but you got yourselves a little pickle. So if you're confused about that, please come see me. I will help you. Number 2. This went fairly well for most of you. A few of you were in left field a little bit confused, so please come see me. I will help you. So for A and B, all you needed to do was read the graph. So if the area was 8 square meters, that's here, and then you would go over and down to find the length. So 2 is one of them, and 4 is the other one. So you could have had either one of these rectangles, but either way, that's a 2 by 4 rectangle. So any way that you do it would be totally fine. You just needed to say a 2 by 4. And notice that the 2 and the 4 were both here, which was interesting. What's the area of the rectangle with length 5? So length 5 is here. Follow it up until you get to the parabola. and go over to get an area of 5. Now some of you, I realize, found out that was a 5, and were thinking this was width, so you did 5 times 5 and got 25. But that's not the case. This is the area, so the area is 5 meters squared. Again, friends, don't forget your units on all these. A lot of you did. The greatest area, that would be the top of the parabola, so that's right here, and that is 9. So that's 9 meters squared. Again, just read it. What are the dimensions? So if that's 9, you go down and you get a 3. So if the perimeter, no, we don't know the perimeter. So if the area was 9, if one side is 3, the other one must also be 3, because 3 times 3 is 9. So the dimensions would be 3 meters by 3 meters. When it says find fixed perimeter, remember they all have the same perimeter, so it doesn't matter which rectangle you use. You could use this one, that's what my arrows were all about. You could use this one, or you could use this one. It doesn't make any difference which one you use. So I looked at this one and said, well, if this is a rectangle, then these sides are 3 and these are 3 as well, so 4 times 3 is 12 meters. If you use the top one, you had a rectangle that was 4 meters by 2 meters, which makes this 4 meters, and this 2 meters. And when you add that all up, you get 12 meters. So any way you do it makes you come up with 12 meters. You needed to either explain or show your work. Some of you didn't show me anything, and that was not good. Okay, here we go. Rectangle has perimeter 80 rather, 80. They said draw the rectangle, label the sides in terms of L. So we made one side L, so that's in terms of L. And then you had to find the W. So what we did was we used the perimeter and solved for W. So subtract 2L from both sides. 2W equals 80 minus 2L. Divide by 2 on both sides, and that gives you 40 minus L for the width. So you put that here, and that's labeling your rectangle using just length. Then it says write an equation for the area of the rectangle in terms of L. So the length is L, the width is 40 minus L, so L times 40 minus L. Make sure you have these parentheses. If you don't, then you're not multiplying fully. This was exactly like the problem over by the bird poster in my classroom that we did for stations, and that's the same problem. So a lot of you found it, and you did a great job. I was very pleased. This is what your chart and your graph should look like. I'll just let you look at this for a second. As I said, I think it's easier if you make a width column as well. Remember, one of the things about the width was if the perimeter was 80, then what that means is the width plus the length would add up to half the perimeter. We've been through that several times, and I think that makes it a lot easier to make the table. So if you go by 5, 0, 5, 10, 15, then just make those add up to 40. So 0 plus 40 is 40, 35 plus 5 is 40, 10 plus 30 is 40, 15 plus 25, etc. And then finding the area from there is no big deal. Estimate the greatest area. It would be the top of your parabola, the vertex, or you could find it right here in your chart. That's another way to do it. So it's 400 square centimeters, and the dimensions are 20 by 20 meters. So again, it's just working with your parabola and your table. So I like that problem. Okay, now we're to the point where my last video stopped working, so I'm going to try and go from here. Okay. Apparently it's still working. Go me. All right, so this was just your factoring, and actually this went pretty well for a lot of you. A couple of you are confused. Now you only had to do one of these, and I gave a little bit of extra credit for those of you who did more than one. So factored form for this one would be x times x plus 2, because this would be x plus 2. Expanded form would be x squared, because that would be this square. And this rectangle would be 2x, so it's x squared plus 2x. Or if you think about it as distribution, you could see it right here, x squared plus 2x. So either way that you think about it is fine. Factored form for this one, the unshaded region, or the whole square rather, is x squared. Oop, I'll do that down here. I like to do the expanded first, personally. So do x squared and then subtract away the shaded area, which would be 1 by x. 1 by x, there we go. So subtract 1x. If you wrote it in factored form, it would be x times x minus 1, because this distance is x, this is 1, so therefore this distance is x minus 1. Okay? Those were not worth a whole lot of points, and neither is either of these, simply because we haven't done it much recently, or we only did it for a short period rather. But you kind of like these, so I'm glad that you would put those on here. So for simplified, this is a lot like distribution if you think about it, because you're going to distribute this division of 6x to both of these. So 24x squared divided by 6x is 4x. 30x divided by 6x is 5. Now, because you have it given here in the original problem, you don't write it on the outside. They just said, please divide. Down in this one, they did not tell you the GCF. You had to find it. In this case, it would be 5a. But then you have to leave it on the outside. So a lot of you did this. You discovered that it was 5a, and you wrote it underneath here. And that's great, so that you could see it to divide, but make sure that when you're factoring out the GCF, you actually leave the 5a on the outside, because you invented this part right here. So 10a cubed divided by 5a is 2a squared. 5a squared divided by 5a is minus a, and 20a divided by 5a is plus 4. So that's your correct answer. I love these SAT extra credits. They're very cool. So here's your substitution, and honestly, these are SAT questions. So we need to substitute -3 in, so you do -3 squared plus 3 times -3 plus 3. Lots of 3's, but you just have to do it. -3 squared? Yep, that's 9. Good girl. Then you have 3 times -3 plus -9. Good job. Plus 3. These cancel, and you get 3. So D is the correct answer. Number 2, we have not really done a lot of this, but I thought maybe you could do it. This is a distribution problem. You have to distribute this and then combine like terms. So the 5a squared minus 5a plus 4 hangs out. Then distribute this. What is a times 3a? And you know how to do that. You just haven't done a lot of it. A times 3a is minus 3a squared. A times 4, actually it's negative times negative, so it's plus 4a. Then combine like terms. 5a squared minus 3a squared is 2a squared. So that eliminates these two. Negative 5a minus 4a. Is it minus 4a or plus 4a? Plus 4a. Very good. Minus 5a plus 4a is minus a. Looks like it might be a. And then plus 4. So a indeed is the answer. So hope you liked it. I'm going to stop this real fast to make sure that it works, and I will see you again soon. Do a good job on your aftermath. Bye.